what a lovely and huge campus. I wouldn't mind strolling around here every day, surrounded with all this landscape. Hello there, I'm kinda lost here. Do you happen to know where the new science center is?
Hello there, and yes, I do know where the building is located. As a matter of fact, I am one of the professors at the faculty. I am Professor Monyan. Are you a freshman here?
That's right, my name is Jasper. Sorry for bothering you, but do you mind showing me where this place is?
Sure, it's just around the corner.
Alright, let's go! Oh, sorry for being rude earlier. I have class in an hour later and I wanna get familiar with the place first. May I ask, sir, is this the destination?
Ha, no worry there. And yeah, welcome to Amherst College new Science Center. It looks pretty huge, right?
You're right. However, I'm wondering what those spiky things on the rooftop are.
Good observation. Those spiky things actually are sawtooth roof, which features array of skylight monitors to induce upward airflow pattern as the roof integrated with the combination of dynamic and convective ventilation. In addition, the design also allows diffuse daylight entering while minimizing preventive excess heat.
Interesting. But with that blood ceiling glass facade, isn't that gonna create several issues such as glare?
Not at all. In fact, our building features a structural triple glazed silicone curtain wall system which achieves U value 0.25 while maintaining a visible light transmittance of 56%. With an integrated automated shade system, it managed to control the glare and the overall lighting level while reducing UV exposure. Since you're interested in this building, do you mind if I give you a tour around?
Oh, really? That would be great. Thank you so much, sir.
No worries. Now let's head into the building.
Wow, the interior is so bright, and yet I feel chilly and comfortable.
The reason is because of the incorporation of chiller boiler system with integrated sensible only cooling panels into wave monitors. The radiant floor slab heating and cooling in order to control the thermal comfort inside this building. When there are more occupants in the space, the carbon dioxide emission being produced increases. This warmer air will then rises up from the space towards the ceiling, whereas the air surrounding the chill beam is cool, causing it to descend back towards the floor, creating convective air motion to cool the space. That's why you would feel comfortable even though the space allows lots of daylight to enter.
Oh, I see. Could you explain further how this chiller boiler system works together?
Put it simply, a chiller boiler system typically includes a chiller, a boiler, pumps, and HVAC control. It's a hydraulic system that uses radiant heating and fan coil system to properly condition a building. Cold water from the cooling tower basin is passed to the chiller to remove heat and allow to produce chilled water, which eventually reduces the temperature of hot, fresh air that flows across the cooling coil. Then the water that takes up the heat will be sent back to the chiller, whereas the cold air is distributed to the interior spaces. And that applies to the boiler as well. Cold, fresh air that flows across the heating coil will increase its temperature, which eventually provides thermal comfort in the building during winter. This system usually is a more efficient and uses lesser energy than a standard forced air system.
That's cool, but how does a chill beam different from a typical air conditioner?
Allow me to explain. Both chill beam and typical aircon uses fan, but the difference is that in chill beam, the fan is minimized whereas aircon uses excessive amount of energy to power the fan. When compared with a traditional HVAC system, chill beam provides superior energy saving by reducing the reheat by 50% and reducing annual fan energy 30 to 40%. Since there are not many moving mechanical parts in the chill beam, thus it is quieter and saves more space.
Amazing.
Haha. Now let's move on to the next destination.
Oh, I just noticed that the water was streaming down in the tubing. Is that anything to do with the building?
Short answer, yes. The water features that you have just seen actually are the rainwater collected from the roof will be sent for filtration, which were subsequently sent into a central reservoir on campus as part of a water conservation solution. The stored filtered rainwater would then be reused to meet the demand of the building, including for the implemented HVAC system. It has been said that these water management strategies, including the surrounding landscape and green roofs, are able to reduce approximately 1 million gallons of potable water per year.
1 million gallons per year. That's a pretty huge amount of water being saved there. This laboratory is huge, and look at those huge containers. Let me guess, is it something that keeps us safe while doing experiments?
Yes, those are actually called high-performance low-flow fume hoods, which is a ventilated enclosure where air and airborne contaminants are captured and removed from the work area by smoke exhaust fans situated on the rooftop. These fume hoods can operate at a lower inflowing air velocity, consuming 50% less energy than conventional hood design. In addition, the smart fume hood sash allows 10% airflow reduction when occupied and 30% airflow reduction when unoccupied, reducing laboratory exhaust rate by 15 to 20% and preventing the space from being over-ventilated.
Oh, I wonder where those harmful gases are gonna be disposed.
These gases will be discharged into the convection heat recovery system through the ductwork before being purified and released into the atmosphere. This system extracts the heat from the gases, then passes it through the air that's filtered in from outside, which will then distribute throughout the space without physically mixing. Similarly, the stale gas from the non-laboratory spaces will be discharged into the system, which is eventually recirculated back to the spaces, thus giving big savings on energy. In addition, each room in this building is operated by the demand control ventilation, which is an energy-saving system that relies on the number of people working in the room. For example, a fully occupied lecture room will provide more fresh air compared to a fully occupied private office.
Oh, wow, that's a brilliant way to discharge the gases while being capable to reventilate the building. These adopted technologies are sure smart and advanced.
That is true. For your information, Amherst College New Science Center was awarded the AIA COTE Top 10 Green Project Awards in 2019 for its standard in design and sustainability. As a matter of fact, with all these implemented energy efficiency strategies, it has been said that this building is a high-intensity laboratory with one of the lowest energy footprint of its typology, achieving energy usage of 91 kBTU square foot while reducing energy usage by 76% compared with a typical research building.
Ah, shoot, I almost forgot my class. Anyways, thank you so much for showing me around, sir. See you soon.
Bye and stay safe.